Hello students, welcome to one more video of Physics Guru. In this video we are going to learn about a special type of constraint motion in which the angle of the thread is not constant. That means when the block A will move horizontal on the table and the block B will fall down vertically, then clearly we can see that this part of the thread is going to change the angle. The angle theta is going to increase actually. As the block A will come forward, the angle theta will increase. In this case, the velocity of the block A and B are not directly related as V1 is equal to V2, but actually even it is related with a factor of cos theta, like this. So in this video we will see the relation between V1 and V2. We will derive this formula that the velocity between the two bodies is related like this. V2 is equal to V1 cos theta. Then we will discuss about the relation between the acceleration also. Although V2 is equal to V1 cos theta, but acceleration A2 is not equal to A1 cos theta. Here A2 means acceleration of the second block and A1 is the acceleration of the first block. In fact, we will derive and see that the acceleration of the second block is given by A1 cos theta minus V1 square sin square theta by h. After that, we will see a shortcut technique to obtain the velocity relations between the two blocks very easily, and then we'll see some problems based on the same technique. So let us proceed further. So first of all, we will derive the relationship between V2 and V1 and angle theta. So the block A is on the table, block B is hanging. A is going with velocity V1 and B is falling down with velocity V2, whereas angle theta will keep on changing. So let us suppose that the height between the center of the pulley and the table A is equal to h, which will be a constant value. And also let us say the distance of the block A from the edge of the table is equal to x. So you see that here a right triangle is getting formed. This is a 90-degree angle here, whose height is h and the base length is x. So we can now tell what is the hypotenuse length. That will be root of x square plus h square. So now the usual method of solving a constraint motion problem is that we should write down the total length of the string. It is also called string constraint. So let us suppose this part of the hypotenuse part of the string is root x square plus h square, whereas this remaining part of the string you consider as length equal to y. So therefore, we should start writing like this. The total length of the string let us say is equal to L. So if from the figure we can clearly see the total length of the string is going to be y plus square root of x square plus h square is equal to L. Then after that, the standard procedure is that we will differentiate this equation with respect to time. Always in a constraint motion problem, write down the total length of the string with the variables and then you differentiate with time. So dy by dt plus the d by dt of this square root, okay? D by dt of this square root x square plus h square is equal to dl by dt. Now let us try to find out what is the meaning of dy by dt from the figure. Let's see here, y is the distance of the block B from this fixed point pulley. So therefore, the rate of change of variable y should be equal to velocity v2. Therefore, dy by dt is equal to velocity v2 plus. Now, how to differentiate this square root function here? As you know, let us revise our basic concept that differentiation of square root of x is equal to 1 by 2 root x. This is the regular formula. But suppose we are having the differentiation d by dt of root x. Then will it be the same answer? Check here what is the difference between these two differentiations. First one is d by dx, second d by dt. t is a different variable than x. Therefore, for this situation, the answer is 1 by 2 root x into dx by dt. This is the real technique. This is called chain rule of differentiation. One must know this technique of chain rule of differentiation. Therefore, differentiation of this root x square plus x square will be 1 divided by 2 root of x square plus h square into the d by dt of x square plus h square following this chain rule is equal to, now this dl by dt would be 0 because L is a constant here. Okay, please note that this length L is actually a constant length. String is not extensible, that's why. Let's continue. Furthermore, we'll get here. So 1 divided by 2 root of x square plus h square will be as it is. Differentiation of x square plus h square. So differentiation of the x square would be equal to 2x and that of h square will be 0 because h is a constant. But once again we have to write down here dx by dt into dx by dt for the same reason here, because we can see that we are differentiating a function of x with respect to another variable t. So we have to multiply extra thing here, dx by dt is equal to 0. Furthermore, we see here that v2 plus, we are getting here 2x divided by 2 times of root x square plus h square. And dx by dt, what is the meaning of this dx by dt from the figure? If you see the diagram, x is the distance of the block A from the edge of the table. As the block A will move rightwards, this x distance will decrease. Therefore, the rate of change of x dx by dt should be equal to velocity v1. However, because x is going to decrease, so therefore minus sign will come for the definition of velocity. Because x is decreasing, therefore dx by dt should be negative value, minus v1. Substitute here, we will get minus v1 is equal to 0. Finally, after cancelling 2 and 2, look at this ratio, x divided by root x square plus h square in the figure. X is the base length of the triangle and root x square plus h square is hypotenuse. So base upon hypotenuse, this is base divided by hypotenuse, is cos theta. Therefore, cos theta into minus v1. Therefore, v2 is equal to v1 times of cos theta. This is our first derivation. We have successfully derived the formula v2 is equal to v1 cos theta. This is the relation between them. It is an advice that this formula should be remembered according to this figure. But now I am going to share with you a shortcut technique by which you can easily remember how can we derive the relation between v1 v2 very quickly without going through this long process of differentiation. See, let us now talk about a shortcut technique. In this shortcut technique, what I am going to do is that, first of all, let us indicate in the figure the velocities of the block A and B. B has velocity v2 and A has velocity v1. Let me indicate v1 along this line. Along this line, the velocity is v1. This is the velocity v1 for the block A. Now, what we have to do is that take the component of the velocity v1 along the direction of thread, like this. This component of the velocity of v1 along the direction of thread would be equal to v1 cos theta according to the figure. Right. Now consider a point on the thread on the right side of pulley and on the left side of pulley. This point which is on the right side of pulley, it is directly connected with the block B. So if the block B is moving down with velocity v2, definitely this point on the thread must also move with the same velocity v2. Similar logic applies here. This point on the left side of the pulley on the string must have same velocity as that of v1 cos theta, which is the velocity of the block along that direction. Or we can say v1 cos theta is actually the velocity of this end of the string connected to block along the direction of thread. That is the velocity v1 cos theta. So definitely every point on this thread must have same velocity, which is v1 cos theta, and every point on the other side must have same velocity v2. But even these two velocities must also be equal, because they belong to the same thread, the same string. That is why the final answer would be that this velocity v2 is actually equal to v1 cos theta. So here we can write down a simple technique that the components of velocity, how to remember this concept is that the components of velocities of the blocks along the string are equal. Components of the velocities of blocks along the string must be equal. So actually for the second block we didn't find any component because that was a very straight direction, that's why. But for the case of block A, the velocity of block A was not matching with the direction of thread, so therefore we had to take the component. Suppose for the block B also the velocity is not along the thread, then you can also take the component of velocity v2 along the thread, and both should be equal. Let's continue to next page. Yes, now let us talk about the acceleration of the blocks. Just now we have found the relation that v2 which is the velocity of block B, this is v2, and this was v1, but we taken a component here that was v1 cos theta, and because both belong to same thread, so both side velocity should be equal, so v2 is equal to v1 cos theta. Now let us try to find out what is the relation between their acceleration. Let us say the block B is falling down with acceleration a2 and block A is moving along the table with acceleration a1. How a1 a2 are related? Are they also related the same way? Is a2 is equal to a1 cos theta? So the answer is no. We might be thinking that just differentiate dv2 by dt, you will get a2, and differentiate dv1 by dt, you get a1. But what about cos theta? Why are we leaving cos theta? Actually, cos theta is also a variable. You know, theta is not constant here in this question. If the angle theta is not constant, then even this cos theta is not constant, and so even this is also a variable. So in the differentiation, even cos theta should also be differentiated. So we will correctly differentiate the equation on both sides in this manner. Left side dv2 by dt, and on the right side we will write down the d by dt, or differentiation of the product of v1 and cos theta. As we are having a product of two variables on the right side, we must use the product rule of differentiation, which says the first function into differentiation of second function. So here first function v1 into the differentiation of second function plus the second function into the differentiation of first function. This is the product rule of differentiation. Now on the left side, this dv2 by dt is nothing but the rate of change of velocity v2, which is a2. So dv2 by dt is a2. So a2 is equal to v1 into differentiation of cos theta is minus sin theta. But again we are seeing that the differentiation is being done with respect to t, not theta. Whenever you do differentiation with respect to another variable, see, cos is dependent on the variable theta, but we are differentiating with respect to time, some other variable. So we have to multiply d theta by dt. This is the rule of the chain rule. Plus cos theta into dv1 by dt is nothing but acceleration a1. Rate of change of velocity v1 is acceleration a1. Finally, we are getting that acceleration a2 is equal to a1 cos theta. I am just exchanging the term, this one, and minus v1 into sin theta into d theta by dt. Okay, let it be equation number 1. But this is not the final answer, because this d theta by dt, it doesn't look good here. Let us find out the value of d theta by dt from this triangle. Once again, let me draw this triangle here, and in this right triangle we had taken this height as h, and the base length of this triangle was taken as x, and angle theta. From this right triangle we can see, we can write down that h by x is equal to tan theta, or we can say that x is equal to h divided by tan theta. which is also equal to h into cot theta. Now we can differentiate this equation once again. Dx by dt is equal to, h is a constant, just keep here. Cot theta differentiation is minus cosec square theta. Minus cosec square theta. But because once again we are differentiating with respect to time, that's for d theta by dt again will come into picture extra. This dx by dt is nothing but, again you see, x is a variable which is decreasing. So dx by dt should be minus, and it should be velocity v1, because rate of change of distance is velocity. So minus v1 is equal to minus h, and reciprocal of cosec square theta is sine square theta, put in denominator here, into d theta by dt. So actually we are getting the value of d theta by dt as v into sine square theta divided by h. This value of d theta by dt we are going to substitute in the first equation here, and let's see what do we get. We will get a2 is equal to a1 cos theta minus v1 sin theta into d theta by dt means v1 sin square theta divided by h. Final answer is a2 is equal to a1 cos theta minus v1 square sin cube theta divided by h. So that's our final answer. This is a very good question for JEE Advanced examination. Let us proceed further. Now time to solve problems. So here is one problem, you see. So in this question, A is a collar. Collar is something which can slide on a rod, okay. Actually this A looks something like this. This A is actually a cylindrical block which is containing a hole inside, and through this hole this rod is passed. So A can slide up and down on the rod. A is a collar that can slide on the vertical rod and is connected to the block B hanging from the string. What is the velocity of the collar when the velocity of the block B is v? So the block B is going down with velocity v, and we have to tell what is the velocity of the block A when the thread is making angle theta with the vertical. Now definitely the velocity of the block A will be along the rod only, like this, because the block A is constrained, sorry, not the block, the collar. The collar A is constrained to move along the direction of the rod only, because there is a hole over there, is passing through the hole. So even though string is making angle theta, but block A can only slide up or down. So let us say velocity is VA upwards. So as I told you in the shortcut technique that we have to find out the component of this velocity, along the string in the direction of the thread. So what is this component here? It will be VA cos theta. Then once again we can say that this point, any point on the string, should have the same velocity VA cos theta, and on this side any point on the string should have a velocity equal to V as that of the block. So, and these two points must have same velocity because they belong to the same string. Therefore the answer is VA cos theta must be equal to V. Therefore VA is equal to V divided by cos theta, or V into sec theta. This is the application of a shortcut technique. Next question. This question has appeared in IIT-JEE 1982. Here you see there are three blocks here. B and C are connected to the passing over pulley, and C also passing over pulley, and both the strings connected together to the block A. And this dotted line is the vertical line with respect to which the strings make same angle theta. It's symmetrical arrangement, same angle theta from both sides. So if the block B and C both are pulled downwards by the same equal velocity u, okay, so let us say these two blocks are going down with the same velocities u downwards. What is the velocity of the block A at this instant when the both strings make angle theta with the vertical? Let us say the block A is going upwards. Obviously the block A will go vertical direction only because of the symmetrical situation. Let us say velocity V. Let us say A block is going with velocity V upwards. Once again applying the trick, shortcut trick, take the component of the velocity V along the thread. So the component of the velocity along the thread will be equal to V cos theta. This is V cos theta. And on this side you see any point on the thread has a downward velocity is equal to U, and this side any point on the string has velocity V cos theta. Therefore V cos theta is equal to U, or V is equal to U divided by cos theta, means U into secant theta is the answer for this question. Next question. If the string is pulled by velocity V, here the string is being pulled with velocity V rightwards, what is the velocity of the block? This one. If the string makes angle theta with respect to the vertical. Now you see, the block is kept on the table, so it will be assumed that the block will be actually moving along the table horizontally with some velocity, let us say VA. Now this angle is 90 minus theta. So again we have to find out the component of the velocity of VA along the string. Let me change color. So the component of the velocity along the string would be equal to VA cos of 90 minus theta. And this velocity must be equal to V given here. So let's write down the answer. VA into cos 90 minus theta is equal to V. Cos 90 minus theta is sin theta. Therefore, VA is equal to V divided by sin theta is equal to V cosec theta is the answer. One last question. Find the relation between the velocities V1, V2 and theta1, theta2. See here, the block A is having velocity V1. Okay, block A is moving rightwards on the table, and the block B is going with velocity V2 on the table horizontally. Both the blocks are moving horizontally on the table, and the string makes angle theta1, theta2 with the horizontal at these two places as shown here. So once again we should find out the components of these velocities along the string. Let's start with this V2. Component of the velocity V2 along the string will be equal to V2 cos theta 2. And here actually we should extend our line this side, outward side. So we can say that the component of the velocity V1 will be this one along this thread. This is the component of velocity of V1. But how about this angle? This angle is same as angle theta 1, vertically opposite angle. These two are equal angles. So the component is nothing but V1 cos theta 1. Now according to the rules that we studied, every point on the string should have the same velocity. Therefore, any point taken here which will have velocity V2 cos theta 2, and any point taken on this side will have velocity V1 cos of theta 1. Therefore, V2 cos theta 2 is equal to V1 cos theta 1. Or we can also write down the ratio V2 by V1 is equal to cos theta 1 divided by cos theta 2. So I hope that in all these examples that I have shown here, which are all very similar but different situations, one can easily use this shortcut technique to find out the relation between the velocities. Very useful shortcut trick. And so therefore this comes at the end of the video, and I hope that you have enjoyed the methods of physics problem solving. Please like my video and also please subscribe the channel. Thank you very much. This is the link of my YouTube channel which you can directly access through the browser. Thank you to all.